Hello everyone and welcome to Butterflies, Pinwheels, and Wallpaper. Investigation 2.2. Our learning target today is that we will determine whether shapes are congruent using measurements and write corresponding parts. Our ACES questions for 2.2 are 13 through 16 and 36. So look in here at the book at 2.2. We are supporting the world with congruent triangles. I'll let you go ahead and read the top part here. On the bottom, it tells us that in this problem, we're going to focus on congruent triangles. And triangles are a very special family of geometric figures, it tells us. They're used in many construction projects to provide strength and stability for those structures. Triangles are able to provide a lot of strength and stability, so we use them quite a bit in construction. This is, for example, this photograph of the George Washington Bridge here, connecting New Jersey and New York City, shows congruent triangles in the bridge's towers. So if you look through here, you see for each one of these squares, we have 4 triangles making that up, and that adds a lot of strength and stability to the bridge. As we look at the problem here now, it says for each pair of triangles, and you have quite a few, we have A, B, C, D, E, and F, okay? We have all of these. It says for each pair of triangles, inspect and measure parts of the figures to determine whether they are congruent. So we could go ahead and grab our ruler to help us measure. I could set this, we could measure line segment XY, and it looks like it is 35 millimeters, and then we could measure line segment BC, and it looks like it is also 35. So based on the one line, it looks like we might be congruent here. We might also measure this line segment and get on the end here. Looks like we are 60, and here we are also 60. So based on side lengths, we look like we could be congruent. Another tool that we could grab might be our, protractor. So we could grab our protractor here and check a couple of angles. If I grab this and put it on, here, we're going to see that this is 90 degrees. Okay, and if I undo that, and come over here and see that this angle, I am about 120 degrees. So if I flip my protractor around, I can almost get it how I want. Then go ahead and bring it down here. I can check this one. Sure enough, that's 90 degrees. If I bring it over here, check this angle. Sure enough, it's 120 degrees as well. So doing a couple of measurements, I can now tell that both of these triangles, triangle ABC and triangle XYZ, that they are congruent. It says if the triangles are congruent, list the corresponding vertices. So what's the corresponding vertice to A? So from XYZ, which one of those vertices is corresponding to it? And then it also says if the triangles are congruent, describe a sequence of transformations that would move one triangle onto the other. So what reflection, rotation, translation, or combination thereof would you need to be able to get this triangle XYZ to fit perfectly on triangle ABC? So those are the 3 steps for each of these pairs of triangles that I want you to do. Triangle A, triangles B, C, D, E, and F. So for each of them, you're going to fill out all 3 parts, okay? If it is congruent, list the corresponding vertices, and then describe a sequence of transformations that would move the second triangle onto the first triangle. All right, that's what you're charged with to do, and they get through that problem and then do ACES 13 through 16 and 36. Good luck, and look forward to your questions and comments when I get back.